So I'm recording another one of these videos about using a matrix calculator for solving systems of linear equations. Linear equations, right? Not non-linear. And to some people, I still use determinants, which is fine. You can certainly do that work, but I mean, this is so much easier. And you take a linear algebra class, you'll have to worry about determinants, but not for this class, and not for Calc 2 either. I mean, that's where I came across it last was in Calc 2. So what I did is I didn't write the systems, but this system was here. Can I write with the board? The system that I pulled this matrix equation from is just to make sure you know how to do that. Let's see, let's annotate it. And here, so the system was 6x plus 4y equals 240, and 2x plus 8y equals 320. So all you got to do to write the matrix equation is you pull, let's see, can I do a highlighter here with this? So all you do is you pull the coefficients in front of the variables, and those are the go in the coefficient matrix. Then you pull, the um, then you pull the variables and you put them in a variable matrix, and then you pull the constants that are on the far side, and those go in a constant matrix. Okay, and then it's that easy. So this one was 3x minus 8y plus 1 equals -6. -1x plus 1y minus 1z equals -2. And this last one was written this way. And so let me come back here. This last one was written 1x minus 3y, and then there wasn't a zero term, so that's why we had to include a zero, and that equals -3. So technically there's a zero z there, okay? Then it's really easy to write these matrix equations. And then how do you use all this stuff to solve them? Well, let me clear all my writing. And so I got that Math is Fun calculator, matrix calculator up. I've got that linked in the classroom. I'll even link it to the post where I post this video in. Okay, and we can use a graphing calculator too if you know how to use a graphing calculator. There's plenty of videos out on how to do that. So what you got to do is, so this first one is a 2 by 2 matrix. So you've got to adjust this fun calculator to 2 rows, 2 columns, and then the coefficient and the constant matrix is 2 rows, 1 column. So we're going to move this one over so it's a 1 column and 2 rows, and then you just got to type those numbers in, and don't miss your negatives. 6, 4. I can't tell you how many times I messed up because I had negative, and you just type them in. Let's see, 2 and then 8. I think this takes the longest. 8, not as long as finding determinants. And then this one is 240, and then 320. And there, so I've got the matrix in. Now, what we've got to do is, if you're watching one of my other videos, what we're going to do is we're going to do the multiplicative inverse of that coefficient matrix. Remember, what we're doing is if you have an equation like 3x here, let me change this back to red ink. It shows up better. So 3x equals 5. What you're going to do is divide by 3 is what you do. But you could also, the reason dividing by 3 works because when I multiply 1/3 times 3, I get 1, because 1's that multiplicative identity. You can multiply anything by 1 and not change it. So that's why we're finding the multiplicative inverse of the coefficient. So for matrices, it just looks different. It looks like a matrix, but it's you multiply that inverse times that matrix 6, 4, 2, 8. You'll get a 1, 0, 0, 1. I won't do that here because I'm trying to focus on solving the system. So what I'm going to do is I'm going to have, let me get a pointer going. I'm going to have the calculator find inverse of A. I want to find the multiplicative inverse of that coefficient matrix. So I click inverse A, and it gives me that. Then what I want to do is I want to store that to matrix A, and then I'm going to multiply that inverse times B. It's like multiplying the 5 times the 1/3 up here. I'm going to multiply this times the inverse. I'm going to A times B. Where's A times B? Oh, there it is. And that's the solution. X is 16, Y is 36. I mean, that's a pretty easy solution. So to make sure, I mean, it's okay to leave it in a column, but I think because it is a system, we're looking for these two lines intersect, we should write it as an ordered pair. I mean, I would like that better if you did that. Okay. So all you got to do is for me to make me happy in this course, write the matrix system and write the matrix equation, use a calculator to get the answer. You don't have to do all the algebra. You don't have to do the inverses. You don't have to do row reduction. That's all row reduction and multiplicative inverse by hand. That's all stuff you'll do if you have to do a linear algebra class. So let's try something that's a little more complicated. So this one is not much more complicated. This is a 3 by 3. So the 3 by 3 system is going to tweak this out to 3 by 3. And this is the 3 by 1, 3 rows, three rows, 1 column. And then you just got to type them in, again, make sure you don't mistype it because data entry is the problem. Let's see, -8, whoop, 8, Dan. Usually when I mess up, it's because I wasn't paying attention. I typed in the wrong number. So -1, 1, and -1. And I got 1, -3, and then 0. And then I'll type in the constant side, -6. You probably can tab this. I don't know. I don't want to have to redo it 2 times, 3 times. The graphing calculator does a really slick job of this too. Okay, so now I'm going to find the multiplicative inverse of that A matrix. So inverse A, and it did that. If I took this and multiplied it by that A inverse, that A function, I get the multiplicative inverse of these looks like, let me get a pen going. It would look like 1 0 0 0 1 0 0 0 1, and that's the identity matrix. If you multiply this matrix times any other matrix, it doesn't change it. Just like 1 times something doesn't change it. Okay, but that's a little more theory than we need to do to do this math. Here, so I'm going to clear that out. I have to clear all drawings. Now, what I've got to do is I've got to save that inverse. Looks weird, but we'll try it. We're going to save that inverse to here. You know what? I'm going to hit inverse A just to make sure I didn't click something weird. Oh no, that's it. Okay, so I'm going to save that back to matrix A, and then I'm going to go A times B, and that's the solution. 3, 2, 1. I mean, we could double check the system, but so this system is a plane. If those 3 planes cross at the intersection point 3, 2, 1. And then this one is, I don't know what it is, planes moving in space because there's 4 variables. Find the determinant. This is a royal pain in the butt. A lot of work. It's so easy with a calculator. So I'm going to change to a 4 by 4 system. I got to change this to a 4 by 1. And then you just got to make sure you type in the numbers right again. Probably ought to pause this video so you don't have to watch me typing them in. Why don't I do that? It's a lot of typing in. Let's see. It's probably going to take me longer to pause a foolish thing than it will be to just do it. So I took the time to get those in there, and I'm pretty sure that I typed them in correctly. I'll take one more look and see. Now, the other mistake I could have made is I could have copied down the system wrong. So we'll see if we get the nice, neat numbers. So I'm going to do this. So again, we're going to do the inverse of A. So ask yourself, what button do I click here to get the multiplicative inverse of that A button? I mean, of that A matrix. So I hope you're thinking inverse A. So I'm going to click on that inverse here. Let me get a pointer so it shows up better than my cursor. Inverse A. That's a much messier answer, but notice those are rational numbers, or maybe they're just doing some error rounding errors. I'm going to save that to A, and then I'm going to do A times B, which is where A times B right there. Okay, this is good. I'm very glad this happened this way. Um, Now, that doesn't mean negative 2.999999 is the answer. What's happening here is it's taking our base 10 numbers, translating them to hexadecimal. I guess you guys at program would know more about it than me. And then it's taking them back to base 10. So when you get a result like this, it's going to be negative 3, negative 2, negative 3, and 2. And that should be the solution. And of course, that's an ordered quadruple. So we'd write it. Yeah, I don't think my upper math would like it if you typed in all those decimals. It just wants you to be so negative 3, negative 2, negative 3, and positive 2. That would be that solution to that system. Okay? So hopefully this convinces you to use this math as fun calculator rather than finding all the determinants or row reduction. I mean, you certainly can. I'll be sad if you do. Let me know if you need some help.